Hello friends, our today's point is marginal cost and elasticity in economics. Friends, this is a part of economics. We will apply calculus, okay? We will see how calculus is useful finding out the elasticity or the marginal cost, okay? Okay, use of calculus to find marginal cost and elasticity. Economics. Friends, first we'll see what is the marginal cost, what is the average cost, then we'll see elasticity. Okay. For that, I'm going to open a graph. Friends, when the just a second, I will give a name. Okay, this is a old graph we have seen already. Okay, I discussed about this. Choose color. Okay. So this is y, this is x. Okay. Let y is the cost, x is the quantity. Okay. In case in previous videos what we did we have written here is f of x, sorry, f of t, this is t, f of t where distance, t where time. Okay, but this is economics. That's why here y is nothing but cost, x is quantity. Okay, the curve and equation is not a straight line, it is a curve. If it were a straight line, okay, then it is, we don't need a calculus. Okay, we need calculus only in case of curves, okay, where it is not straight line. For example, y equal to ax square, y equal to 2 sin t, okay, something like this. There we need calculus because finding out slope is not easy. See here, in general, what we do when we don't know calculus, okay, what we do, just I want to find out the slope at this point. Okay, at this point I will draw a straight line, okay, near to this point here. Okay, and I will try to find out the slope, okay, between these two, suppose x1 x2, and the slope is nothing but the average slope of this line in between these two quantities, okay, x1 and x2. This is average slope, or you can say average cost in between x1 x2, okay, between x1 x2, average cost. And if I want to find out cost at x, okay, or x1, okay, instant this line, okay, this tangent at that point is nothing but instantaneous, or you can say marginal cost. Okay, it is cost at x, means at exactly that quantity. Okay, and this average cost is the in between two cost, in between two quantities. Okay, for example, starting from here to here, suppose we did production has done in between these two quantities. Okay, for example, 1 ton, 2 ton. Okay, and I will like to find out the cost. Okay, then you can try this. Okay, and if you want to find out production of that exactly 1 unit after a ton of production, okay, suppose up to this here, okay, I want to find, then you have to use marginal cost. It means you want to find out the tangent equation of slope of that tangent at that point. Okay, similar case as that of finding out velocity at an instant. I think everything is clear to you, don't need to save it. Referring to fifth, see here, x is quantity, y average cost. Okay, we have seen delta y by delta x. just a second. Okay, suppose this is a straight line. Actually it is not, but suppose, and this, I want to find out slope of this. This is delta y, this is delta x. Okay, if you find out slope of this average line, it is a average cost. And if you find out, trying to find out slope at exactly this point, is nothing but marginal cost. Okay, or slope of this tangent. Okay, marginal cost is nothing but extra cost to manufacture an extra unit. Okay, the average cost is the uh, cost in between 2 points. Okay, for example, if you just, I will give example, okay, to understand better. File, new, don't need to save it. File, new. Okay friends, manufacturing, or just say printing a book. Okay, we need ink, paper, machine, okay, electricity. Okay, to print a book. Okay, when you start this production of printing book, okay, suppose you start at this point. Okay, after production of x1 books. Okay, x1 book, you have to, when you start, you need to pay for electricity, you need to pay for ink, you need to pay for paper, you need to pay for machine. Okay, when you start printing a first book. Okay, means, and after printing x1 books. Okay, when you find out the, after printing x1 books, when you find out the cost, what is the cost up to x1 books. Okay, all of the cost of these will get included in the, or it is average cost, average cost. Okay, but when you will try to find out cost. Okay, you will, when you try to find out cost at exactly x1. Okay, then the previous things will not get included. Okay, just what is the cost at this. Okay, to print an extra book. Okay, this is the marginal cost. I think that's it. It's clear to you. File, new, don't need to save it. File, open. Okay, I think it is clear what is marginal and average cost to you. Okay, average is related to the past. Okay, from starting of the production, and marginal is just what is the cost at the present of this book. Okay, that's it. Let delta is the extra cost. Okay, okay, see here, if y equal to x square. Okay, this is the equation relating the cost and quantity. Okay, here y is the cost, x is the quantity. Okay, if you want to find out the average cost per extra ton. Okay, in here it is written in tons. Okay, this for ton of production, delta y by delta x, x square by x, simply x. Okay, this is average cost. Okay, now if you want to find out the marginal cost, which is nothing but a slope at slope at an exact x quantity, is 2x. Okay, dy by dx is nothing but 2x. Marginal cost is nothing but slope at x or derivative. Okay, marginal cost is clear to you, I think. Don't need to save it. Friends, now we will move to the elasticity. This term of this marginal cost, okay, here it includes cost, and cost can be, just a second, cost can be measured in terms of rupees, dollars, dian, or so many units, okay, uh, differ from country to country. So we need one unitless, so we need a unitless term, okay, here it is elasticity, to find out how this production and cost, okay, quantity or cost will get varied, okay, how this we need, just we need term which describes the relation between cost and quantity, okay, or supply demand product, okay, supply demand and cost, okay, and that term is elasticity, okay. Here cost increase, okay, elasticity is nothing but a ratio of marginal to average cost, okay, that's it. You have to remember, marginal can be found out using derivative, and average is just average, okay, you know average already. Or you can in another way you can say, what is the effect of on cost when we increase the production or quantity, okay, how, in see here, this delta y by y is indicates increase in cost, okay, in case in fraction, okay, or in percentage, and delta x by x indicates how it will increase in cost affects the increase in quantity, okay. Limit del x tends to 0, this can be simplified into this, and it is nothing but ratio of marginal to average cost, okay, and this is called as elasticity. Don't need to save it. Here are two curve, okay, x versus y, so y versus x, okay. See here, one is the demand, one is the supply. Supply is a straight line, demand is this, okay, and the, when where these two curves meet, okay, it is called as equilibrium price, okay. So optimum price, when you fix price of your product this, okay, price at this point where demand and supply curve meet, your economy will get stabilized, okay, it will get stabilized. And another case is monopoly or no competition. For example, you are the only producer of a particular product, okay, is the monopoly, okay, because you can set any price of your product. And in case of supply equal to demand, okay, if everyone fixes this price, then there will be no competition, okay, or you can say, sorry, perfect competition, okay. No one can raise the price. If someone try to raise the price of the product, the customer will move to the another supplier. Important equation, okay, base equation is y equal to c. Suppose the demand is y equal to c by x, okay, at price x, and supply is y equal to c by x at price x, okay. This is a straight line, okay, this supply curve, straight line. And when you find out the elasticity is going to be 1, and when, in case of y equal to cx square, say y equal to cx square, okay, if you find out elasticity is -1, okay, we will take module of -1. Elasticity always measured in positive sign, okay, +1, okay. These are the bases. Friends, this curve indicates when e equal to 0 and when e equal to infinity, okay. First thing, see here, equal to 0, whatever is the price, farmer cannot suddenly grow more wheat, okay. In that case, elasticity is 0 or is perfectly inelastic, and economics is really very unstable. In this case, friends, in case of equal to infinity, okay, water can be supplied at any price, okay. See here, in case of equal to 0, okay, what you can fix whatever the price, but the farmer cannot grow required quantity of the wheat suddenly. And in case of water, the, uh, we can produce, oh sorry, we can sell or supply any amount of water at fixed price, okay. This is a case of infinite elasticity, or perfectly elastic, okay, perfectly elastic. We don't know to say it. Suppose you have curve relating quantity and cost, okay, curve relating quantity, cost, okay, is this, okay. It is something like y equal to cx square or cx cube, something like this. You can already, you can find out this elasticity is n, okay. This is simple. If you don't understand, see here, just first find out what is the elasticity. Elasticity is nothing but ratio of average, okay, av, average to marginal, okay. Okay, what is the average of this? Sorry, marginal to average. Okay, what is the marginal here? Just see x raised to n by x. Okay, just write down here. And what is the marginal? Just find out the derivative, which is nothing but n into c. When you simplify it, you will get the n. Okay, that's it. Don't need to save it. That's it, friends. I will say more important point related to derivatives, okay, such as maxima, minima, in our future videos. Thank you.